This screencast is about the definition of the derivative. We've been really talking around this definition for some time, and I've mentioned it explicitly in class, but I thought this podcast could provide a nice summary of it all. So what is the derivative? The derivative, which we write as f prime of some input a, we call that the derivative of f of x at a if we want to talk about it. So you can say the derivative of the function f of x at x equal a. We often also simply read this as f prime of a is another way to read it as well. Either way, we mean the derivative. So what is the derivative? We've got a few ways we can think about it. The derivative is the limit of the average rate of change as the interval goes to 0. Remember, the average rate of change is always over an interval. So if we shrink that interval up until it goes to 0, we're going to get the derivative. But if I'm going to calculate this, I need a little bit more on it. So if we say that the interval has size h, if I'm going to take a time interval, say, of total length h, then we're talking about the limit as h goes to 0. So what is that going to be? So the derivative is the limit as h goes to 0. You can think of this as h gets smaller and smaller in magnitude of the average rate of change. So of the average rate of change here, which is going to be the rise over the run, or the change in output over the change in input. And it'll look like this: f of a plus h minus f of a, that's the difference in output over that interval, over a plus h minus a. And it's useful to note here, what is the interval we're talking about? In this case, x is going to be going from a to a plus h. This is assuming h is a positive number. The interval is from a plus h to a if it's a negative number. But just think from a to a plus h. That's how we find the average rate of change. But we need to put a limit on this. So when we want to write it all together, we're going to say f prime of a is going to be equal to the limit as h goes to 0 of f of a plus h minus f of a, and notice the bottom of the fraction I wrote above ends up just being h, because those a's are going to cancel out. So we would read this: the derivative of f at a is equal to the limit as h goes to 0 of the difference quotient, that is of f of a plus h minus f of a, all over h. Okay, so let's continue this. Let's continue this with a problem. Our problem's going to be to take a look at the function f of x equals 1 over x, and to find f prime of 2. So let's first take a look at the function. We can see from the graph here that this function is always decreasing. It's decreasing as we come in through large negative numbers. And then there's going to be an asymptote at x is equal to 0, and it starts to decrease again as we go through the positive numbers. If I try to sketch in a little bit of what a tangent line looks like, I could get an idea of what the slope might look like through something like this. So this is going to be my tangent line. And it's definitely going to be a negative number, it looks like. So I have an idea of what I'm looking for. while I'm doing this problem. The procedure here is going to be to find the difference quotient and simplify. So that's our sort of step one, find difference quotient. And simplify that difference quotient. So what's the difference quotient? It's the rise over the run, but I'm going to be looking at the interval as x goes from 2 to 2 plus h. So what I'll end up doing is f of 2 plus h minus f of 2 all over 2 plus h minus 2. And that's going to be what? It's going to be the slope of my secant line between x is equal to 2 and x is equal to 2 plus h. So what do I get when I find this? I'll get 1 over my input, 1 over 2 plus h, minus, again, 1 over my input. This time my input is 2, so minus 1/2. All over, the 2's are going to cancel out on the bottom, and I'll just have an h on the bottom. And now you want to go, yikes, I don't know what I'm going to do with this or how I'm going to simplify it. There's a couple of strategies you could use to simplify here. I'm going to use a strategy called clearing the denominators. That means that, remember, I can multiply any fraction by a form of 1. Here's the form of 1 I'm going to multiply by. 2 times 2 plus h over 2 times 2 plus h. How did I pick that form of 1, you ask? I looked at all of the denominators here. This denominator and this denominator. I'm going to multiply by all the denominators, because then as I distribute this through, I'll be able to cancel out all of the denominators. So when I distribute that 2 times 2 plus h on the top, it's going to be 2 times 2 plus h times 1 over 2 plus h. And then I'll distribute it to the second piece. It's 2 times 2 plus h times 1/2. And on the bottom, it'll be h times 2 times 2 plus h. Why did I go through all this trouble? It seems like I just made the situation worse, but in fact, I'm going to be able to cancel those denominators out here and cancel the 2 out here. What do I get when I do that? Well, I've got a 2 times, those two things became 1, right? And there's a 1 on the top here, so I've just got 2 times 1 minus those 2's canceled out, so I've got 2 plus h times 1. The denominator, or the bottom of the fraction, is still h times 2 plus h. I tend to like to write it with the constant in the front, if I can. So I can simplify now just a little bit more by taking this and realizing that this is going to be 2 minus, I now can distribute that negative, 2 minus h. And on the bottom, 2h times 2 plus h. The 2's cancel out, and I'm left on the top with a negative h, and on the bottom with all that same nonsense. I sometimes notice that people want to, to be sort of steadfast and do as much algebra as you can, expand that to multiply the 2h times 2 plus h. But generally, if you have denominators, bottoms of fractions, and they're factored already, leave them factored. It's not generally going to help you to expand them out. That's not universally true, but it is often true. So I can simplify this just a little bit more, and this is a piece of why I want to leave it in that factored form. Notice I have an h on the top and the bottom, right? So if I rewrite this as negative 1 times h over 2 times 2 plus h times h, I can see there's an h over h there, which will cancel out since h over h is equal to 1. And I end up with negative 1 over 2 times 2 plus h. So that's, what was I doing? I was finding the difference quotient and simplifying it. But I have another step here, because remember, my goal is I want to find f prime of 2. So finding the difference quotient and simplifying was just the first step. Now I want to take the limit as h goes to 0. use that arrow to kind of mean as approaches. So if h is getting closer and closer to 0, what do I do now? Well, now I just get to plug in for h. There's no problem just plugging in for h. And if I do that, that's going to tell me that f prime of 2, that quantity that I'm trying to do, it's going to be the limit as h goes to 0 of this negative 1 over 2 times 2 plus h. When I plug in, I just get negative 1 over 2 times 2, or in other words, negative 1/4. So the slope of the tangent line, right, because remember, this is also equal to the slope of the tangent, that is going to be negative, just like I thought it was going to be. It's also a relatively shallow negative number, which, you know, at least seems reasonable based on the graph that I could have. I could try to visually see, does my approximation of the tangent line seem to have the same slope? And it looks like it's got from here to here that I've got something like a rise of about 1 and a run that looks like it's going to be about 4. So that would make negative 1/4, right? If this is going to be that it's falling by 1 and over here it's going by 4. It at least looks plausible that that's the right answer, and I always like to check for plausibility. So what would I do next? Next, I'd say let's just do a zillion of these problems. I'll ask you to find f prime of negative 1 and f prime of 12 and f prime of 5, all for this same function. Let's say f of x is going to be equal to 1 over x. But you know what? As I think I've admitted in class before, I'm really lazy. I hate doing more work than I have to. I don't want to do 3 separate problems there. That's going to really, really annoy me. But we can do one big problem that does it all at once. Can we actually find f of x? F prime of x, I mean. Can I find the derivative at a generic value x? How would I do this? I'm going to use the same steps as before. So I'm going to find the AROC, or the difference quotient. Find the difference quotient for the interval from where x is now going to go from x to x plus h. So notice I'm using this other interval notation here. This means that my x values are traveling from a generic value x to x plus h. So this interval is h long, just like the one that I wrote before. And I'm going to do all of the same calculations now that I did before. So here we'll plug in x plus h for the x value, and we'll end up with 1 over x plus h. Remember that our function here remains 1 over x, so then when I subtract f of x, here I'll have 1 over x. And x plus h minus x ends up becoming just h, because those x's cancel out. I'm going to deal with this the same way that I dealt with the previous problem, by clearing denominators, multiplying by x plus h to get rid of that one, and x to get rid of this one. So you can see that after I've done this, in this case, when I multiply by the first one, I get this in orange, where the 1 over x plus h and the x plus h cancel out. And then the red one, where 1 over x and the x cancel out. So I'm left with, so finish up that algebra on your own, and then come back here and note that I'm left with x minus x plus h, all over h times x plus h times x. And got an extra parentheses there, and that's going to leave me with minus h over h times x plus h times x on the bottom. When I cancel out those h's, because h over h is just 1, I'll be left with negative 1 over x plus h times x. We're so close to being done, but not quite, because my last thing to do is say, well, I know what f prime of x is. It's the limit as h goes to 0 of this quotient. But what do I get when I do that? I'm just plugging in h is equal to 0. I'll get negative 1 over x squared as my answer for f prime